So I'm saying that certainty equivalent coefficient is a model that is used to evaluate the most certain outcome or to determine the most certain outcome. So most of the time when you are trying to start a business or when you're budgeting, you always use assumptions, right? When you're budgeting, you use assumptions and say that this is what can happen. But there is a possibility that it may or it may not happen, right? Now, if it happens, then that is a good thing. So how certain are you? Like, for example, when you are in Form 4 or high school, probably you are expecting to get an A minus. That is something that you're expecting. But what you are certain of, you are very certain that you could easily get at least B plane. So you are sure of B plane, but you are hoping for A minus. Now the one that you are certain, come what may, the one that you are sure of, come what may, that is what now we call certainty. Now, if you're doing business, sometimes the cash flow that you're seeing might not be exactly what you can get, or what you're expecting might not be exactly what you will get. But there is an amount that you are certain of. That is what we call certainty equivalent. That part of certainty is what makes certainty equivalent coefficient.
Good evening. Mr. Deno, good evening.
Good evening, Florence. Welcome. So, Florence, we are starting a topic or subtopic called certainty equivalent. It is still under capital budgeting. When you are budgeting, there are things that you are doubting. For example, during Christmas, you can make your budget and say that you think price of unga can be around maybe let's say that 200. That is what you can be saying, that 2 kgs can be 200. But then somebody can say that I think the prices have gone up. If the prices have gone up, there is a possibility that it could have gone up to maybe 250. So as a finance person, you can make your budget and say that come what may, the price cannot be more than 250. You are at least sure that the maximum is 250, but you are thinking that it can be 200. Now, the one that you are certain with, the one that you are sure of, is what we call certainty equivalent. So if I was having cash flows, if I wanted to start a business and I have some cash flows, those cash flows might not be realized as I expected, but they are at least the minimum that I know must happen. Now, maybe if the cash flow was 10,000 per month, and then I'm saying that the minimum I can get, the one that I'm very sure of, can be at least I can get 8,000. It means that out of 10,000, 8,000 is a sure bet. Then therefore, this 8,000 is the certainty equivalent. It is the amount that is equal to what I'm certain of, what I'm sure of. I expect 10, but at least the minimum of 8, I am very sure of. Therefore, 8 is certainty equivalent. So if this was 100%, then what is the certainty equivalent percentage? What is the percentage of certainty equivalent? The amount that is equal to certain or sure bet. How much is the percentage, or what is the percentage of certainty equivalent? If the expectation was at 10,000, it is 100%. Can somebody try? What is the percentage of certainty equivalent? Type. 80%. Thank you. 80%. Because you are expecting 100%, but you know that the minimum you can get that you are very sure of is at least 8,000. So that 80% is what we mean. So that is the percentage of certainty equivalent. So if you are given 0.8, which is the same as 80%, then we are saying that this is the coefficient of certainty equivalent. This is the coefficient. It is the coefficient. It is the percentage that you can multiply with 10, the full amount that is expected, to give you 8. So it is this coefficient that will make the possible become the reality. This is the reality. So out of 100%, the reality is only 80%. That 80% is the coefficient. So model is just a formula. So we are saying that we have to now bring our cash flows to at least a figure that we are sure of. A figure that we are very sure of. So that is what we are trying to say. So what is the certainty equivalent of 20,000? 20,000, given that coefficient is 8%, is 0.8. Certainty equivalent is how much?
16,000. 16,000.
So if the coefficient is 80%, what is the certainty equivalent? 160. Thank you so much. 160. It means that out of 20,000, only 160 you are sure of, because the coefficient of certainty equivalent is this. So that is well gotten. I want you now to write and take some notes.
Right.
I want to take some notes.
Na nyanya upate uanze kupatia beauty, hata unaweza tukarangia maharagwe. Unajua kukaranga maharagwe inakarangwa tu kama sukuma, hakuna process
Sorry for
nyingine
that.
hapo. Enda
Let me mute
ukarange.
everyone. So I want to say that under certainty equivalent, I wanted to make a paragraph and say
Karanga
that
maharagwe.
under this model, risky cash flows are converted into risk-free cash flows. Under this model, risky cash flows are converted into risk. Under this model, risky cash flows are converted into risk-free cash flows using certainty equivalent coefficient. Under this model, risky cash flows are converted into risk-free cash flows using certainty equivalent coefficient model or certainty equivalent coefficient. So it means that when we say that a cash flow is risky, it means that we are not very sure with outcome. So like 20,000 is risky because it may or it might not happen. So we are not very certain. So therefore we convert it to a risk-free, what we are very sure of, by multiplying it with a certainty equivalent model or coefficient, certainty equivalent coefficient. So under this model, risky cash flows are converted into risk-free cash flows using certainty equivalent coefficient model or coefficient, certainty equivalent coefficient. Illustration. Florence, have you gotten me? I saw you logging out. I'm saying that under this model, risky cash flows are converted into risk-free cash flows using SEC. Using, you can say using SECs. How do you read that? Yes, just read it how you can, but that is a plural of the coefficients. I've said this. Yes. Now, I want you to have an illustration. Illustration. So let's say that the time, and you know the time is the same as the period. when you are generating your cash flow. So we have year 1, year 2, and year 3. Then the expected cash flows are here. The expected cash flows are there. Then we have the certainty equivalent, the coefficients. So year 1 is 10, year 2 is 8, year 2 is 8, then year 3 is 7, then we have 0.7, that is the coefficient. So this one is a coefficient. So it is certainty equivalent coefficient. So, and then we have 0.6, then we have 0.5. Right, that then proceed and say additional information. Number 1, initial outlay is 8.5 million. Initial outlay is 8.1 million. Sorry, 8.5 million. Initial outlay, that is the investment cost, is 8.5 million. Cost of capital, that is Roman 2. Cost of capital is given as 12%. Cost of capital is 12%. Then we have risk-free rate of return is 8%. A risk-free rate of return is 8%. A risk-free rate of return is 8%. A risk-free rate of return is 8%. Required. There are first additional information after this additional information. The first one is that initial outlay is 8.5. The cost of capital is 12%. Risk-free rate of return is 8%. Required. Calculate NPV, that is the net present value. Calculate NPV. Calculate N for net present value. Calculate NPV using certainty equivalent coefficient. Using SEC approach. Certainty equivalent coefficient approach. So, what are we doing here? We are told to calculate NPV. And we are told that we have to use certainty equivalent approach. What does that mean? The question is calculate NPV, net present value. NPV using CEC, that is a SEC approach. Certainty equivalent coefficient approach. So that means that they want to get NPV using the approach of the most probable, the surest policy or the surest approach. This one is the normal cash flows, but we are told that when using this, you are converting the risky cash flows to risk-free. And that is why you are given the risk-free rate of return as 8%. So if you are told to calculate NPV, in a normal way, we could have used the normal cash flows, which have got some risk element in them, to calculate our NPV. But they know that this one has got risk. They are now telling you, can you use a model that is risk-free? That is the certainty equivalent. So do your NPV using the most possible or the most certain cash flows. That is why they're telling you use certainty equivalent approach, the most certain cash flows. The risk-free rate of return is given as 8%. Then calculate NPV using SEC approach. Calculate NPV using SEC approach. That is the question. So let's look at the solution. Let us look at the solutions. So we have the certainty equivalent coefficients. So the first thing that you need to do, if you are told like that, then it means that you have to use a risk-free rate of return as your discounting factor rate. Remember in the previous example that we have done, we were using a certain rate of return, which is discounting factor rate. And we would say that R, or 1 plus R into This R that we're using was not risk-free. That rate of return has got some risk. Now we've been given a rate of return which is risk-free, and it is only good that we associate it with the risk-free cash flows. We associate this risk-free rate of return with the risk-free cash flows. The ones that we have here have got risk. For us to convert them to risk-free cash flows, we need to now multiply them with the certainty equivalent, so that we are saying that out of 10, how much is certain? How much is the risk-free cash flow? Can somebody tell me? Our expected cash flow is 10, but the certainty equivalent is 7. How much is risk-free cash flow? How much is certain? Certain meaning that we are sure of it. It does not have any risk. So only 7 is risk-free cash flow. It is certain. Therefore, it is good to associate it with a risk-free cash flow. It is good to associate risk-free cash flow with the risk-free rate of return. So for that matter, we need to get our risk-free cash flows. So you call them risk-free cash flows. So here we have 7. The second one we have, what is the second one? The next one, what is the risk-free cash flow in this? Or most certain cash flow? The certainty equivalent cash flow is 4.8. That is it. It is called risk-free or certainty equivalent cash flow. What about here? We have 3 points. So those are our new cash flows that we are going to use. Because we are told to use that model, we are now going to use them as our cash flows. We forget about the risky ones. So it is 7, 4.8. Then now we calculate our normal NPV now. And we're going to get NPV, which is risk-free NPV. So our time is there, our cash flow, which are risk-free cash flows are 7. We have 4.8. We have 3.5. The next thing is the normal discounting factor. But now we use risk-free rate of return. We don't use the normal rate of return, risk-free rate. So risk-free rate is given us 8%. So can somebody give me the discounting factor? Because now we have risk-free cash flows, we have to have a risk-free rate of return. So can somebody give me discounting factor for the first year, year 1? Is it PV or PVFA? Is it PV or PVFA? Is PVFA, so get me PVFA for year 1. No, PVF, sorry. PVF, so get me PVF for year 1. Here. Those who are having calculator. 0.9259. 0.9259. 0.9259. The second year. Second year. 8573. 0.8573. Third year. Then for third year. $7,938. So what is our present value? Multiply this and this. For year 1, present value is year one. Present value for year one. $6.4813. 6.4813. That is a present value which is very certain. A risk-free present value. Year two. Year two. Year two. Also, you have given me. Okay, fine. So let's have that. 4.115. 4.115. 0. Then we have 3.7738. Okay. Now, what is the total present value? Total present value, just add them. I know this should be 1. If I add this with this, should be 9. If I add this and this, should be 6. If I add this and this, so that should be 16. I'm not very sure if I'm okay. I'm just trying to think about it. If those correct figures are correct, then it should be that. The last one is 2 point. The last one is 2 point. So if it is 2 point, then this should be 13. I'm not very sure. Has somebody given me the correct answers? Third one, okay, fine, I've changed it. NPV is 13 point. Oh, so I mixed it somewhere. So this should be 7. Did we carry something? That is okay. 9. 1. This one is. Are you sure? It's false. No. Unless somebody gave me wrong figures. NPV. What is the correct figure first before NPV? Is it 13.7? 13.3746. I don't see that, but I'll just add them. I know you guys have given me wrong figures. I'll use them the way they are. So let me just write for you 13 point. This 7. You manipulate wrong figures. 46. If you are wrong here, because you add 3 and 8, you cannot get 6. So it means that you guys have given me wrong figures here. So mnataka ni calculate, and I warned you not to make those small errors. I warned you not to make those small errors. 7783. 7783. That one I can add 383. So then that one is now okay. So that can be 6. And then now we have this. This and this 6, 4. That's okay. I think that now makes sense. That now makes sense. So it is 1343. 3743. Fine. So our NPV is normally present value minus IO, which is the same as 13.3746 minus initial outlay was 8.5. 8.5. This gives you, initial outlay was 8.5. So this gives you 4.88, right? You can round it off like that. Is that correct? Is it okay? 746. $87.46. So 87.46. Fine. So that is how you do it. That is now what we call a certificate equivalent. So always remember, whenever you're told to give NPV, whenever you're told to calculate NPV, one thing that you should not forget is to advise. Don't forget to advise the examiner or the person who has given you the job. Always advise, give advice. So which advice can you give here? Which advice can you give on that NPV? I've actually told you how to do it. Can somebody give us advice? What is your advice on this project? Accept. Yes. Accept the project because the project is viable. Always advise whether the project is viable or not. So you say accept the project. Now, let us now look at something quite serious. Look at your papers, past paper 2022. Open your past paper 2022 and share in the meeting. Share here, 2022, August 2022. Share August 2022. I want us to look for one question there where they were trying to test the same concept. Haraka, please. Haraka. Share, accept the project. Thank you. Share past paper 2022. So go to 2022, August, question number 1. There it says, the link was interfered with, okay, maybe. Sorry for that. It says that a project requires an initial investment of 500,000. A project requires an initial investment of 500,000. It is expected to generate cash flows of 200,000. So that is what is expected. We know the IO, initial cost of investment, we know. And we are being told that the expected cash flow is 200,000. It is expected to generate cash flow of 200,000 per annum for the next 5 years. Additional information: the firm is indifferent between a certain amount of 181,347 at the end of the first year and the expected amount of shillings 200,000. The risk-free rate of return is 5% per annum. Are we all together there? Are we seeing the question? Kila mtu anaona? Are we all seeing the question? Waziri anaona, Topista, yes, ahead. So we are saying that you want to start this project, but you are undecided, you are indifferent. Indifference means that they're almost the same to you. You don't know how to make a decision. Sawa. And kama zinakaa similar. So you want someone to advise you. That is what the examiner is saying. That this manager is indifferent, ameshindwa kuchagua. Now you coming in to advise. So ameshindwa kuchagua whether he should take an option or 181, which is very certain, where it's very sure of, or 200 that is just expected, but it's not very certain. The question is question number 1. August 2022, question number 1. So the risk-free rate is 5%. Now on this project, this is the same project that can either give you 200, which is expected, or 181, 347, which is certain. What is the certainty equivalent coefficient in this question? Can somebody get me certainty equivalent coefficient? The certain is 181, 347. So IO is given as 500,000. Certain amount is equal to 181, 347. Expected is equal to 200,000. What is the certainty equivalent coefficient? So certainty equivalent coefficient, just like the one for 20,000, we got 16,000. It means the certainty equivalent was 16,000 all over, this one is certain, all over 20,000. And we got 80% or 0.8. That was the coefficient of certainty equivalent. What is the certainty equivalent? What is the sec here? Certainty equivalent coefficient. What is it in this statement? Get me the full figure that you're seeing. Avoid those decimals most of the time. Get me the full figure. We say that you do decimal, 4 decimal places to be more accurate. Thank you. So our certainty equivalent coefficient is 0.9067. The examiner is saying that the net present required, the net present value of the project incorporating certainty equivalent coefficient, SEC, tumeiona. Roman 2, advise the management on whether the project is worthwhile. So how do we get the NPV? Number 1, you need to get the certainty equivalent coefficient. The project is going to stay for how long? 5 years. It's going to give you 200,000 for 5 years. So what are the cash flows in year 1? So you need to get NPV, and for us to get NPV, we need to know the cash flows in those years. The cash flows in those years. So solution. That is December, August, August, yeah. August 2022, question number 1. So solution is that first thing you need to determine the cash flows. Determine cash flows that are certain. So that means that we know what SEC is. So our SEC is equal to 0 point, that is 3, 181, 347, all over 200,000 is going to give you 0.9067. So therefore, our cash flows that are certain, because we need to get certain cash flows for us to get the certain NPV. Discounting factor will be risk-free. So our certain cash flows determine certain cash flows. Certain cash flows. So in year 1, our cash flow is in year 1, our cash flow is 0.9067 times 200,000. In year 2, we have, in year 2, we have 0.9067 raised to 1 here. This one is raised to 2 times 200. In year 3, we have 0.9067 raised to 3 for 3 years times 200,000. In year 4, 0.9067 raised to 4 times 200. Then we have year 5. We are raising because this is certainty equivalent in year 1. But as you proceed to the second year, the cash flows become more uncertain. What we are saying is that if somebody is going to give you any amount today, you can be 100% sure that you can be paid. Ikifika next year kwambie wacha ningoje next year nitakupea, utakuwa na doubt kwa sababu there are a lot of factors that can affect the possibility of him giving you the money. We could be inflation, loss of job, change of attitude, a lot of things. So as the period proceeds, the possibility also changes. So the possibility that we got here, which was very certain, this for now, it is certain now. But in year 2, it now changes. The possibility is not remaining the same because of the risk in the future. Year 3 also changes. So you need to keep on changing them up to the last year because the cash flows, the possibility of getting that cash flow cannot be the same throughout due to factors. So we'll calculate it using the rest figures, yes. So you rest them like that, 975. So those are the figures that you're going to get. So get me the first one. Sasa wewe unajua, inaweza kuwa ako na nia mzuri sahihi, lakini mambo hubadilika, sio? So next year things can change. It might become more difficult for them. So even the amount that you're certain you can get, it becomes more difficult for you to get it. So the possibility of getting that money changes. 181, 340. Now see, to calculate to sahihi. You're getting 181, 340. Or maybe you use the full decimal places. Because this one should be the same as this, unless decimal places iko na shida. That's why you need to use as many decimal places as possible. So it was 906735. Sawa. Let's use the full decimal place. Needs to be as accurate as possible. So we're having 0.906735 press 1. 0.906735 press 2. 0.906735 0.906735 0.906735. That's why I was insisting that the more the decimal places, the more accurate you are. Now try this one if you're going to get this same amount, because that is the certainty equivalent date. So it should be actually giving you. Are you getting that? Confirm. Inakupea hiyo figure sasa. Okay, so that means that now we should use this. So get me the second one. These are now the cash flows. So what is the certainty equivalent for year 2? The cash flow for year 2. Certainty equivalent cash flow. How much are you certain in year 2? I want it to make sense for you. Even though this person akona nia mzuri, in the first year, he's telling you that we can actually get this. It's obvious that in year 2, the level of certainty cannot still be the same because of other factors. So you need to raise that one like that. So we have, Florence has given me all the figures, 164, 430, 434, 149, 098. Then we have 135, 192. $122, 583. 583. Now the cash flows you can see, because of the future risk, they keep on changing, though you are certain that you can get it. But the certainty equivalent varies from year to year. So these are the cash flows. Now our discounting factor. So these are the cash flows which are certain. Certain cash flow. Then discounting factor. Are we using PV or PVFA? Somebody is giving me a different figure. So it is naweka kwa decimal places. Sawa. You'll be more accurate. So try and examine many decimal places so that you can be more accurate. Thank you. We use PV, right? So what are the discounting factor for year 1? Use 5%, which is the risk-free rate, because these are now they have been changed using this certainty equivalent into a risk-free. The only risk that they have is because of the future differences. It is not because of the expected cash flow. Expected cash flow, you can get the same, but even that cash flow can be affected though you are sure of it. PVFA, you are dying in silent. We use PV kwa sababu the cash flows keeps on changing. Let me unmute you. Please don't make noise. Haujaona, si unaona sasa zimechange. This one, they are changing. Florence, before you talk, let me explain to you this thing in a simple language. Unaweza kuwa uko na rentals. These are rentals. The rentals that you're having, you are expecting maybe they are like 10 rooms. And you're estimating that when I start getting the money, I can get maybe those 10 rooms, all of them zimejaa, and I'll get 100% money. There is a possibility that at some point, kuna zingine zitakuwa na vacancy. Not because of the economic conditions, but because you might miss or lack customer or tenants. So if you are supposed to get 100% rental income, then you are saying that there is a possibility that I might like somebody to come and occupy the space. So I might not have 100% occupancy. The amount that you are setting, at least the minimum that you can get, especially in year 1, is 80% occupancy. So that 80% is the certainty equivalent. However, in year 2, you can still get 80% which you can work with. But in year 2, there are other factors that can affect the business. Like, for example, the value can deteriorate such that mtu akaangalia hii nyumba anaona hii ni nyumba mzee. Sasa hataki kuingia. But you still expect at least ijazwe 80% ikuwe occupied. But there are factors that can affect it. Number 1, political instability can be one factor which you cannot foresee now. That is why, even though we were certain 90%, but we are doubting in year 2, the economy might not be very good. So with that certainty, we can't provide a 90% to say that in year 2 we still get 181. In year 2, we reduce it. In year 3, You could be having things like competition. Mtu amekuja akajenga nyumba safi next to yours. Tenants will go there and they might leave yours. That is an assumption. But we still expect at least 80% occupancy. You cannot say that at that point now 40%. Your certainty equivalent was 90% or 80%. Only that as things go, it is not like the customers are not coming. They are coming, but there are factors that can affect them that can make your revenue to keep on changing. So even though this one was a risk-free cash flows, because we've taken away the element of doubt. So what we are having here is surety. In year 2, even that surety can vary. So in year 1, we are very sure of this. We need to adjust so that in year 2, we don't have a high expectation. We reduce our expectation to 164 to 149. If things go well, we maintain 181, we are okay. But if competitor comes in and beat another one next to us, we know we are going to be affected. So we keep on reducing as the time goes into the future. We don't even know what can happen. Therefore, at the end of the day, the certain cash flows that we're using are irregular. They are not the same. In year 1, the cash flow, which we are very certain with, is 181. In year 2, the cash flow, which we are now very certain with, is 164. So they are changing, and therefore, out of the 5 years, they are not regular. All of them are different. That is why we're using PVIF and not PVIFA. If we are very sure that year 1, year 2, and year 5, they will all be 181, then we use PVIFA. But because we are taking precaution, we are only using the risk-free cash flows, the ones that at least we are sure with them. Therefore, we are using these ones. Do you have any question, Florence, now? Go ahead. Thank you. Now, therefore, we are using PV, and that PV, you can be able to get the figures. Get me now PV factors. The formula for those who are joining now is just 1 plus 1, 1 plus r into negative n. That is PV. For PVFA, we have 1 minus into 1 plus r negative n. All this under r or over r. Yes, over r. That is PVFA. A regular cash flow which is the same throughout. This one we have only taken what we are certain of for each period. Thank you so much, Ruth. Now we have 0.9524. 0.9524. Then we have 0.9070. Then we have 0.8638. 0.8638. We have 0.8227. We have 0.7837. Now, we are going to get present value, which is now risk-free. You can calculate them and get present value. This times this, it is a risk-free present value. Then at the end of the day, you can subtract the answer that you get here, total here, the answer that you're going to get, you can now subtract the IO, which is 500,000. Is it 1,000 or million? 500,000. So that you have your NPV. Then you go ahead and advise the client to accept or to reject, depending on whether NPV is negative or positive. You can now advise. That one I'm very sure that you can manage, because that is Roman number 2, advise the management. You can do that. I'm very sure you can't let me down there. Proceed. The last one side is 0.7835. Thank you. 7835. 35. Thank you. Now from here you can get your NPV, right? Leave a space. Weka hapo total. Put the total here, and then now get that total minus IO, which was 500. Your answer should be 157. Should be something like 157 point 157 1.157 913. 157 913. Some of you, when I give an assignment like that, they don't have time to complete it. I want you not to be one of them. Please try and complete it. I will move to the next area so that you can move very fast because I'm also tired. I need to go. Hiyo utamalizia. So, you know that question when they was set in exam last in 2022, and then they say that the firm is indifferent between a certain, somebody alikuwa anasoma kama a certain, a certain, not a certain and a certain. So you need to know what the examiner is setting so that you know it is a certain, meaning that is sure, not a certain, which is just mwingine, sio mwingine, sio ingine. Okay? Yeah. Let's proceed. Or can I stop there so that you guys can rest? Because this other one can take time. Let's take a break to malize ingine kesho. So go ahead and complete it. Tomorrow we shall do risk-adjusted discount rate, which is topic, which is the number 5 one. It's called RAD, risk-adjusted discount rate. In the bracket, RAD. That is the next one. So when we are done with that, we shall do decision tree, then inflation. So I think by next week we should be almost done. I'll try to make sure that at least next week we are done with topic number 1. We need like 4 lessons. You got 1, okay? So I think you are at least. Somebody else needs to try and see. Cindy, nimesema hii ni ya kesho. Then next week we need like other 4 lessons and then we are okay. Sasa hii ni ya kesho. Kama umepata hiyo uko sawa. 9:13. 9:15. Bado ni sawa tu. I think just about rounding off and then we are okay. Sasa. So wacha tufanye hii kesho and then next week tukifanya 3 lessons we should be done with topic number 1. This is the most difficult topic because it is wide. Tukimaliza hiyo na topic 2, the rest sasa ni mbio. The rest are okay. So if I call you next week for a makeup class, because we need 4 lessons, kindly avail yourself. Hata wewe umechoka. Okay, good night. Sawa.